Okay, we're in this section on rotation of conic sections. It's not an easy section. For one reason, there's a lot of computation and algebra in it that makes it difficult. What we did, though, we talked about a standard form of a conic section, you know, ax squared plus bxy plus cy squared plus dx plus ey plus f. So I really want to concentrate on what you're expected to do in this. First of all, you know, hopefully you've listened to the lecture. You've tried to make some sense out of what we've been saying. But I want to summarize what you really need to boil down to, the steps. All right, so step number one, make sure your problem's in the form that we say it should be in. You know, the ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. The condition that we want to meet over here, that b is not 0, though. So the term with the xy in it, right, is actually, if it were 0, it would be a much simpler problem. We'd be back in the other sections. But once we introduce a term with xy in it, we've got troubles. And the troubles are going to be as follows. You need to identify the a, b, and the c. Then you need to solve an equation, the cotangent of 2 theta. We've derived this formula, a minus c over b. All right. Then you have to make this substitution over here. X equals blah, blah, blah. Y equals blah, blah, blah. Substitute into that over there. A lot of algebra, a lot of arithmetic for some students. And then you're going to get something that's really simple. And what's going to be simple is you're going to eliminate the bxy in the problem. We went through some examples already. Now what we're going to do is we're going to narrow this down. And I'm going to summarize as we narrow these problems down what you need again to focus in on. All right. Let's not worry about the rotational invariance. Let's just go start doing the examples now. I'm going to switch to the whiteboard. Just give me a second to do so. I got to plug it in. Okay. So what I want to claim again is what you're focusing in on is this, you know, some of the formulas that we've given you. So the one thing I want to point out over here is just reading problem number 1 in the example. What does it say? It says, you know, the x prime, y prime coordinate system has been rotated theta degrees from the xy coordinate system. The coordinates of the point xy is given. So I want to point out what they've given me is they've given me x, they give me x is 7. And they've given me y is minus 7. All right, and what did they say? Here's what they said. They said that they rotated it through an angle theta, and theta would be equal to 45 degrees. What you're expected to do is figure out the x prime, y prime now. And there's many ways to do it, but I want to concentrate on the formula. The formula is x equals x prime cosine theta plus, I'm sorry, not plus, I'm daydreaming again. I do that often enough that I have to stop daydreaming. Minus y prime sine theta, and then y would equal x prime sine theta plus y prime cosine theta. Well, I'm thankful for 45 degrees because it actually looks like it might be easy to do. So let me write this down. And what's x? X is 7. I don't know x prime. That's what I want to figure out. And what's the cosine of 45 degrees? 1 over root 2. Minus, I don't know y prime. That's what I'm going to find. What's the sine of theta? Again, pretty simple. It's 1 over root 2. All right, let's put y down now. What's y? Minus 7. All right. Now what do you get? You get x prime times the sine of theta, and theta is 45 degrees, and again, sine of 45 degrees is 1 over root 2, plus y prime times the cosine of theta, which is 1 over root 2. This worked out pretty nicely. What I notice is that these, you know, I have 2 equations with 2 unknowns in it. I think it's pretty easy to deal with. What I'm going to suggest you do over here is just add those 2 equations together. And what would you get? Well, 7 plus minus 7, 0. And then you would get 2x prime over root 2, and the y primes would just magically disappear. And that's good news. Now, what does this tell me? This tells me x prime must be equal to 0. So I know what x prime is now. Now, here's what you're going to do. You're going to take this, and you're going to substitute it back into one of those equations. Right? I'm going to take the first equation because it's just there, and I'm going to write this down. So 7 equals Well, if x prime is 0, that first term would disappear. And what are you left off with? Minus y prime over root 2. This can also be solved for y prime. What's y prime going to be equal to? Well, let's take a look at it. It's going to be minus 7 root 2, a very simple equation to solve. What was their question? Find x prime, y prime. And we did that. All right. So again, what I'm saying, like, really not a bad problem to do. Make sure you, excuse me, look at the answer key to make sure that when you see the answer key, they list the point, and this is the point x prime, y prime, as being 0, comma, minus 7 root 2. All right, make sure you look at that. All right, let's do number 2 now. And number 2, far more difficult. All right, so I'm going to point out, if I were doing the problem, I would want to make sure that it's in the proper form. And someone says, what's the proper form? It's that ax squared plus bxy. Well, this looks pretty good. So I'm going to write this down now for you. A is 2. B is 4 root 3. And cy squared, well, c has to be minus 2 now. Now remember the formula that we're going to use for this. The formula we're going to use is the cotangent of 2 theta is equal to a minus c over b. What do you get? Well, what's a minus c? That's going to be 2 minus a minus 2, which is 4. And what do you get on bottom? B, which is 4 root 3. This is 1 over root 3. Now this is me. I don't like the cotangents. I'm going to write down the tangent of 2 theta is really the root 3 over 1. So I'm going to say this sort of like, I understand the triangle now. And what's the triangle? The triangle is looking at the tan of an angle. Well, I'm looking at a reference triangle, right? And what's that reference triangle going to be? This one over here. So root 3, 1, and this would be 2. So, what's this angle over here? 60 degrees. Well, 2 theta is 60 degrees. So what is theta? Theta is 30 degrees. All right. So this is step number 1. Make sure you got the proper form, identify the A, B, and the C, and then solve the equation cotangent 2 theta equals A minus C over B for that angle. The angle turned out to be 30 degrees now. All right. What's my next step? It's tedious. I'm not saying it's not tedious. My next step is to just write down the transformation. And I'll put this down for you. X will equal x prime times the cosine of theta minus y prime times the sine of theta. All right, let's keep going. And I'm going to do that, but I'd say, take your time. There's no rush to an answer on this one over here. It's going to be, so for some reason, it's very difficult to do the manipulation. I'm sorry. I should have wrote not theta, but 30 degrees down. Let me get my eraser out. All right, y is going to be equal to x prime times sine of theta. Again, theta is 30 degrees, plus y prime cosine of 30 degrees. Well, let's write this down. And again, this is the tough part. I'm not saying it's going to be easy for you, right? So what do you get? X equals, let's see, what's cosine of 30 degrees? That's going to be root 3 over 2, right? What's sine of 30 degrees? That's going to be 1/2, right? I'm going to write this a little bit differently. 2 root 3 x prime minus y prime. Let's write y down. What's that going to be? Well, the sine of 30 degrees is 1/2. Plus the cosine of 30 degrees is root 3 over 2. I'm going to write it a little differently. It's going to be 2 x prime plus root 3 y prime. All right, here comes a really tough part for students. All right, if you can get this far, I say go to the next step if you can, but a lot of students struggle with this. And I want to point out what they're going to struggle with, plugging this in. If you look at it, there's quite a few things I have to know, right? Quite a few things I have to know. For example, I have to know what x squared is in the problem. I'll write this down for you. For me, I'm not going to say it's terribly difficult to do, but for some students, it's almost impossible, right? If I'm squaring x squared, I want to point out what I'm doing. I'm squaring x. I'm really squaring this thing over here. And what would you get? Let me write this down for you. You would get 3x prime squared. It's going to be tough. I'm not saying it's going to be easy for you. And then what do you get? You get minus 2 root 3 x prime y prime plus y prime squared. What else do I need to know? I need to know y squared. It's in the original problem. And what am I doing? I'm squaring y now, and I think it's pretty easy to do. What do you get? 4. On top, you get x prime squared plus 2 root 3 x prime y prime plus 3 y prime squared. What else do I need to know in my problem? I need to know what x times y is. Well, I think I can do that. I'm looking at it. Again, I want to put what I'm looking at. I'm looking at x and y. It's up here. And I can multiply those two together pretty rapidly. And again, so when I say rapidly, nothing's rapid. A machine can do it rapidly. But, I'm going to do it 2 times 2 on the bottom is 4, right? Let's see. You would get root 3 x prime squared, right? And then you would get, let's see, you would get 3 x prime y prime minus x prime y prime, which would be 2 x prime y prime. And then what do you get? Minus, let's see what you get there, root 3 y prime squared. All right. All right, here comes the tough part. I got to plug it in. And someone's plug it in where? Into the original. And I want to point out the original is one of the things in the original is actually 2 x squared. I do see that. And what's 2 times the right side? Well, I'll get my eraser out. Put that down for you. This thing disappears and becomes a 2. All right. Now, what am I multiplying the y prime by? Minus 2. All right, well, let me write that down for you. Multiply both sides by minus 2. This would become a minus, and the bottom becomes 2. All right, I'll erase that. All right, what's the x prime multiplied by? 4 root 3. Well, you need to multiply both sides by 4 root 3. So what's nice about this? Well, the bottom would disappear. I'm multiplying by 4 root 3. The 4 disappeared, right? And I'm multiplying by root 3 now. What do you get? Well, I'm going to use my eraser over here. I'll be very careful. This here becomes 3. I'm multiplying by root 3. All right, let's do the next term. The next term is going to be 2 root 3. And the next term multiplied by root 3, so that's going to become just minus 3 here. All right, erase this, put minus 3 here instead. All right, it's work. All right, so someone says, what are you doing now? Well, I want to point out what I'm doing now is I'm going to write it down for you. We're going to do 2x squared minus 2y squared plus 4 root 3 xy plus 20 equals 0. Well, you know what? I want to do these two first. And I have them written down. I'm right over here. I'm going to combine those two. And what would you get? I'm going to be really careful here. So I'm looking at it. And I got the 2x squared. And I got the minus 2y squared and combined together. So that's going to give you, I got a common denominator of 2 there, right? I'll put this over here. And what do you get there? Well, 3 minus 1 is 2. All right. And then what do you get? Well, you'd get, minus 2 root 3 x prime y prime minus 2 root 3 x prime y prime. That's minus 4 root 3 x prime y prime. Let's go to the next one. It's going to be y prime squared minus 3y prime squared, which is minus 2 y prime squared. Now what I want to do, I want to add 4 root 3 xy. So this guy's being added on now. I'll put that down for you. Plus, there's a common denominator, 2. And we get 6 x prime squared plus 4 root 3 x prime y prime minus 6 y prime squared. Just did this guy. Now plus 20 equals 0. Do the work. Push this out. Yeah, it's a lot of work. Common denominator 2. And let's take a look. This plus this, 4. I'm sorry, 8. I'm thinking forward. Let's keep going. This plus this. Well, thank God it disappeared. Didn't like them anyway. Then this plus this. That's minus 8. Plus 20 equals 0. Let's put this down. Things are getting much simpler. 4 x prime squared minus 4 y prime squared equals minus 20. Now what I can do, divide both sides by minus 20. That's like dividing every term by minus 20. What do you get over there? Y prime squared over 5 minus x prime squared over 5 equals 1. Okay, now what? You need to identify what this is. What is it? It's hyperbola. All right. Now, certainly someone says hyperbola, the center of it would be 0, 0, right? Let me put this down for you. Center 0, 0. Let me do the vertices of that, which is really not that bad to do, actually. It would be, let's see, the x would be 0, and the y would be plus or minus root 5. All right, let me keep going through that. I'm going to put vertices down now. Would be 0 for x, plus or minus root 5. All right, what does the thing look like? Sort of like this over here. I'm going to put my asymptotes in. And never quite good at that, but I guess I could put that down here. I want to point out, this is the x prime, y prime system. That's all it is, x prime, y prime. All right, so let's take a look at it. And talk about the foci of it. And the foci, I think I might have, just give me 1 second. I think I made a mistake somewhere. No, I didn't make a mistake. I'm sorry. I'm looking at that. I made a mistake somewhere. The foci is going to be, let's see, 5 plus 5, which is 10, root 10. So foci. And they're over here somewhere. What do I do going from the center root 10? So it's going to be 0 plus or minus root 10. And here comes a problem, though. What are you doing with this thing? It's really, something's been rotated. And what's been rotated? This has been rotated 45 degrees. All right, let me take a look at a picture. And I just graphed this x prime, y prime business over here. This is our goal over here. All right, graphing is always difficult. And I want to point out, I want to look at a better graph over here. And this is the better graph. What are we doing? We're rotating it 45 degrees. I hope you realize that this is a pretty accurate picture drawn over here, much better than the one I did. But I want to point out the one I did was actually x prime, y prime. This is the graph of x, y. So what are we saying over here? It's this graph here, rotated 45 degrees. And that's a better picture over there of that thing rotated 45 degrees. Right? What's this line over here? It's just a straight line that's been rotated 45 degrees. So it's going to be y equals 1 over root 2 x. And the other one, looking at it, just perpendicular to that, which would be, if it's perpendicular, and again, if this one is y equals 1 over root 2 x. The other one, this one over here, would be y equals, well, negative for circle, that would be minus root 2 x. You can probably do that if you want. All right. So that's a lot of work. There's no doubt about it. There's a lot of work to that. All right. I want to make sure that you look at the answer key, though, to make sure that some of the steps are put down for you and the answers are put down. And what I mean, the answer is the goal. I want to point out what the goal is again. This is our goal. Once we get this, the graph is generally easy to put down. And then rotating that graph 45 degrees is also relatively easy to put down. All right. So let's go see if I can look at the next problem. And I think I've done, yep, I'm going to go page number, the next page. And that's going to be problem number 3. It's really the same type of problem, right? And someone says, what do you mean same type of problem? I'm seeing that this is written in standard form. And if it's written in standard form, I'd like to identify what the A is. A is 13. The B is, and again, this is written in standard form, is going to be minus 6 root 3. And the C is going to be 7. All right, so what do? Cotangent of 2 theta. Let's see, it's going to be A minus C. That's 13 minus 7. That's going to be 6. Over, well, think about this, over B, which is minus 6 root 3. All right, what does this give me? Minus 1 over root 3. All right, I don't like cotangent, so I'm going to write this down instead. Tangent 2 theta. That's going to be minus root 3 over 1. Well, I had somewhat of a problem here. I'll tell you what the problem is. The problem is I got to figure out the angle that does that. And I know it's a reference, but if I'm going back to the tangent function looks like this over here. So I know that, 2 theta, I'll write this over here for you, would equal, the angle that would produce that. And I know it's between minus 90 and 0. And what angle would give that to you? Minus 60. Plus, I hate to do this to you, but it's going to be 180 degree K. Let's divide both sides by 2. And you can get minus 30 degrees plus 90 degree K. Now what I have to do is I have to find an angle between 0 and 90. So if you chose k to be 0, you get minus 30. I don't want that. If you chose k to be 1, though, what would you get? 60 degrees. All right, so I'm going to write that down. Theta is 60 degrees. Okay, let's go to the next step, which is writing down that transformation. Here it comes, it gets tough. I'm not saying it's going to be easy for you. So x is going to be equal to x prime times cosine 60 degrees minus y prime sine 60 degrees. And y is going to be x prime times the sine of 60 degrees plus y prime cosine 60 degrees. Well, I have to do this now. I mean, it's work. There's no doubt about it. Cosine of 60, right? Cosine of 60 degrees is going to be 1/2. So I get x prime over 2 minus sine of 60 degrees is going to be root 3 over 2. So I get root 3 y prime over 2. Let me write this a little differently. And yeah, I know it's work. Let's put down y now. Well, it's going to be x prime sine of 60 is root 3 over 2 plus the cosine of 60 is 1/2 y prime over 2, or a little differently. Okay, again, if you go back to the original problem, someone says, well, what do you have in the original problem? A lot of stuff. I have 13x squared down there. Now, I want to just simply write x squared down first. My claim is it's really not difficult to write down. What's x squared going to be? Well, the bottom would be 4. Then you get x prime squared. Okay. And then you're going to get what? Well, minus 2 root 3 x prime y prime plus 3 y prime squared. Again, if you look at the original problem, let me just put what I'm talking about over here. I know it's a lot of work. We're looking at this over here. I need 13 of those things. I'm going to write that down for you. 13 x squared. Let's write this down. 13 x prime squared minus 26 root 3 x prime y prime plus 39 y prime squared over 4. Right, I'm going to put down y squared now. And what's y squared going to be? Well, 4, 3 x prime squared plus 2 root 3 x prime y prime plus y prime squared. But again, if you look back at the original, right, I really want 7 of those, and I'll write that down for you now. So what's 7 y squared equal to? 4, 21 x prime squared plus 14 root 3 x prime y prime plus 7 y prime squared. All right, now what else do I need? It's tough. I'm not saying it's going to be easy for you. I need x times y. Again, I want to point out what we're doing over here. This is x, this is y. We're multiplying these two together over here. Doesn't look bad. 4. And you can get root 3 x prime squared. On the end, you're going to get minus root 3 y prime squared. And in the middle, what are you going to get? Well, you're going to get minus 3 plus 1, which is minus 2. x prime y prime. All right, take a moment. 2 times 2 is 4. That's the bottom. Root 3x prime squared minus root 3 y prime squared. In the middle terms, if you look at it, it's going to be minus 3 x prime y prime plus 1 x prime y prime, which is minus 2. Now, someone says, what are you doing with that? Well, if you look back in the notes, I want to point out what I mean by that. You're multiplying by minus 6 times root 3. I'll put this down for you. All right. It's tough. Now I'm going to write it down. This is really tough. I'm hoping you're willing to try, though. All right, I'm going to reduce. Let's not reduce. What do you get over here? 4. What do you get on top? Minus 6 times 3 is minus 18 x prime squared. Then what do you get? Plus 12, right? Because minus 6 times 2 is 12. Root 3 x prime y prime plus 6 times 3 is 18 y prime squared. All right. Someone says, what do you want to do now? It's going to be tough. But what I want to do is take 13x squared. I want to add it to 7y squared. And then I want to combine it with this minus 6. Write this down over here. Minus 6 times root 3xy. All right, let me write that down for you. If you look at the original problem, it's 13x squared minus 6 root 3xy plus 7y squared minus 80 equals 0. We're actually trying to do this here. All right, let's see if we can do it. And I'm looking, I got them all circled up. All right, all circled up. And I know there's a common denominator to all 3 of those terms of 4. All right, let's take a look at it. You got 13x prime squared and 21x prime squared and minus 18. All right, 13, 21, and minus 18. What's that going to give you? Well, let's take a look. 13 and 21 is 34. 34 minus 18 is 16. All right, I'm going to go to the x prime, y prime now. You have minus 26 plus 14, which is my root 3, plus, minus 26 root 3 plus 14 root 3 plus 12 root 3. Well, if you add that together, what'd you get? 12 root 3 plus 14 root 3 is 26 root 3s, and 26 root 3s minus 26 is none. This is good news. They disappeared. Let's go to the y prime. What do you get? 39 plus, y prime squared. 39 plus 7 plus 18. Oh boy, that looks tough. 39 plus 7 is 46, 56, 66, 64. That's plus, right? Yep. Minus 80 equals 0. Someone said, I wonder if I ever make mistakes. And I make mistakes all the time, but I got an educator. I'll look at it later. If I make a mistake, though, I got to go back over my work. What does this give me? Something pretty simple. 4x prime squared plus 16 y prime squared is equal to 80. I'm going to divide both sides by 80. I'll write that down for you. Let's see, what do you get? X prime squared, that goes in 20 times, plus y prime squared goes in 5 times, is equal to 1. All right, my gut feeling here is that, certainly someone says, I wonder if that's right. Well, I'll tell you, so the number worked out really nicely. This is our goal, though. We've met the goal. Question is it correct? Look at the key and you'll see it. All right. So what I'm going to do now, I'm going to say, what is it? It's an ellipse. Clearly it's an ellipse. So I'm going to draw my picture down. This is a picture X prime, Y prime. I'll never do great pictures. I know that. And I'm looking at it. And I'm going to say, if I set Y to be 0, X prime would be plus or minus root 20. Not a great looking picture. And if I said X to be 0, Y prime would be plus or minus root 5. And let me put that down for you. And what does it look like? Look like this over here. All right. I guess I could do the center 0, 0, right here. I guess I could talk about C. C would be root 15. And what does that mean? Focus are over here. So the foci, you got, plus or minus root 15 over here. Put this over here for you. All right, it's not a great picture. But the question is, I don't think they wanted that picture. They want the other one. So let's talk about the other one. What's the other one going to be? It's going to be that picture rotated 60 degrees. Let's take a look at a better picture. It's right over here. What I did, I rotated that thing 60 degrees. All I've done. All right, the picture's right over there for you. All right, this is a good picture here. Why is it a good picture? Machine did it. Machine did that picture. I just took that ellipse that I just drew and rotated it 60 degrees. All right, let's keep going. And let's make sure we're doing okay over here. I think we just did number 3. And get the next page. And I guess we'll do, there's a picture right there again. Let me go to number 4. All right. So when I'm looking at number 4, it says, sketch the graph of the degenerate conic. I want to point out what the word degenerate means. It means it's lost the characteristics of what a conic is. It's not a conic. And someone says, how would you know that? I don't know that by looking at it. So what I'm going to do is just simply see if I can graph it. They say I can graph it. So I'm going to assume I can. I'm going to just put this down here. I'm glad there's no XY term in it. But if there were, I'd have to do a lot of work. So I'm going to just do what I've done in the past. My assumption looking at it sure does look like a circle. Let's put this down, plus y squared. Let's see, plus 8y. And minus 41. This is exactly what we have done in the past. Complete the square. What does that mean? Well, completing the square, what you're doing is you're taking half of that number, which is 5, and squaring it would be plus 25. You're writing 25 to both sides. And you're taking half of this number, which is 4, and squaring it, which would be 16, and you're writing 16 to both sides. So what do you get over here? X plus 5 squared plus y plus 4 squared is equal, let's see, well, minus 41 plus 25 plus 16. Let's see, 25 and 16, 31, I'm sorry, 21, 31, 40. Oh, look at 0. That's crazy. So what do you have here? If this was a circle, what would it be? Center. Sure does look like a circle. It's going to be minus 5, comma, minus 4, and the radius would be 0. It's degenerate. What are we saying over there? It's a single point. What's the single point? Minus 5, minus 4, over here somewhere. It's just one point. That's all it is. There's only one point that satisfies that equation. What is that point? Minus 5, minus 4. All right. So let's go to number 5 now. Consider the following equation. I don't have the questions down, so I'm going to look at my questions and see what they were. The first thing they say, use the discriminant rule. And I'm going to claim over here, I'm not a big fan of it, so I'm going to skip it. I'm going to skip that discriminant. All right, I'm skipping A. So A was, discriminant. I'm going to skip it. All right. Now, if you need to look at the rule for it and you can copy the rule down, I'm not asking you to do that. All right. So B is a little more difficult. And I want to point out what B is. B says this. You are going to use the quadratic formula to solve this for y. A lot of students they say, how could you have ever done that? Let me write it down then. So 4y squared, right? What comes next? I got this. The next term would be the term with just the y in it. So I'm going to say it's going to be plus, let's see, xy plus y. The other thing is going to be what's left over. And what's left over, I'll write this down for you, plus x squared plus x minus 6. It's nightmarish. Let's talk about this. 4y squared plus some multiple of y, which would be x plus 1 times y, plus something over here. Let me point out what this is. A is 4, B is x plus 1, and C is x squared plus x minus 6. Yeah, it looks nightmarish. No doubt about it. Let's write this down now. What are you going to get? Y would equal, make sure you know what I'm going to do here, quadratic formula, twice the A, which is 8, the opposite of the B, plus or minus, I know it's nightmarish, B squared minus 4 times A times C. All right, let's go through the work. And yes, I know it is work. I'll put this down. Y equals, I got an 8 in the bottom still, minus x minus 1 plus or minus. I got to simplify that inside, and it looks tough. Let me do it on the side for you. All right, I'm going to do it on the side for you. X squared plus 2x plus 1 minus 16x squared minus 16x plus 16 times 6. That's going to be 60 and 36, 96, right? So what do you get? 97 minus 14x minus 15x squared. All right. All right. That's what our goal was, believe it or not. Our goal was to solve for y in terms of x. Look at the key, and you should be staring at that. And if you're not staring at that, that's not good. All right. So here comes the question now. They want you to use a graphing utility, and I want to switch screens, and I want to start talking about using a graphing utility. All right. So let me do another share with you. And I'm going to share what we just finished. I'm going to use a software package, and you're free to use whatever you want, including Wolfram Alpha. And I'm going to use a package called, you know what? Let me use Wolfram Alpha. And I'll tell you what, everyone has access to this. All right. What I want to claim in Wolfram Alpha, it's kind of amazing what Wolfram Alpha can do. One thing it can do, and I want to point out what it can do. It can graph this guy over here. Let me just put that down for you. X, let me tell plot, P-L-O-T, X squared plus XY plus 4y squared plus X plus Y minus 6 equals 0. All right. Now, I want to tell you something about Wolfram Alpha. What it does for me, it actually, tries to understand what I'm typing in there. Sometimes it doesn't, though. It gets kind of crazy results from it. But I want to look at the typeset version, see if it's the same, and see x squared plus xy, 4y squared plus x plus y minus 6. What is it? It's a rotated ellipse. That's all it is. All right. Certainly if I do that by hand, it's a lot of work. You can do it though. Now, of course, what I'm going to do is I want to also do this thing. Now, remember, we just spent a lot of time trying to, solve that, and I'm going to see if I can plot that. All right. So I'm going to say plot, right? Y equals, well, I got the top, and the top is minus x minus 1 plus, but it's also minus. I'm going to do one at a time. Plus the square root. I'm just typing what I'm seeing. And it's going to be 97 minus 14x minus 15x squared. That's the top. Divide by 8. Okay. My claim is this over here. People make mistakes typing. The one thing nice about Wolfram Alpha, though, it actually is going to interpret what I've typed and typeset it for me. And I want to make sure what it typeset is what I thought I said to do. And I'm looking at it, and I think I did pretty good. Now, what does it do? It gives me this over here. Now, someone says, what is that? It's kind of distorted, but it's half of that picture we gave you before. Let's draw the other half. All right, I want to see if I can do it. And I don't know if I can do it. I'm going to give it a try. And it's not plus that, it's minus that, right? Let's see if it can do it. I don't know. Maybe it can't do it. If it can't, I'll go to Grapher, don't worry. Yeah, I couldn't do it. I'm sorry. Let me go to Grapher. Oh, wait, I'm sorry. Maybe it did do it. No, it's really not giving what I want. And what I'm going to do is going to go to Grapher. All right, so let me just pull this on the side. I'm going to copy my work. No need to copy that down again. And I'm going to go to Grapher. Give you 1 second. And Grapher. And I'll just do a real simple graph over here. I just did a copy paste. I like your picture better, by the way. Put another graph in. And again, you're free to use whatever software you want. And that's going to be plus. This will be minus. I got that. I want to graph the other guy down. And I want to see if I can go backwards in my skill set here. I see this right over here. I'm just copying what I did in the past and to retype. And what's nice about this, it really does that. I'm going to start turning them off and on. There's the full picture. All right. What's this guy over here? Let's look at it. I hope you can see that, right? It's like the bottom half of it. What's this guy over here? It's the top half. Again, I'm hoping you're seeing what we're doing over here. All right. You know what? Let me get rid of the grid. Give me 1 second. I'll get rid of that grid for you. All right, let me go back over it and talk about this. I'm going to put different colors down for you too. Inspector, let's make that red and magenta. All right, let's make this one, I don't know, blue. You have a tough time doing this in Wolfram Alpha, I'll tell you that. And let's make this one green. I think you get the idea. You see it. You see it. You see it. All right. You see them all. This is good news. Software is nice to have. All right. Thank you.